In this video, we'll be integrating ln of 1 minus a over b times x dx. First, I'm going to let u equal 1 minus a over b times x, and then the derivative will be negative a over b dx. So here a and b are just constants. Now the inside becomes u, so we have ln of u, and if I multiply both sides by negative b over a, I get that dx is negative b over a du. Now I can factor out the constant, so we have negative b over a outside times the integral of ln of u du. In order to integrate this, we're going to let f equal ln of u, and then dg will be du. So this is using integration by parts. The derivative of ln of u is 1 over u du. The antiderivative of du is just u, because what we're looking at here is taking the antiderivative of 1. So the antiderivative of 1 is u. And so now we have f times g minus integral g times df. So make sure to keep the negative b over a outside. And then we have ln of u times u minus the integral. Well, if I multiply u with 1 over u du, the u's are going to cancel, and I'm left with du. Now, again, we have integral du. Think of this as just 1 times du. And then antiderivative of 1 is just u. And then don't forget to include the constant at the end. We have let u equal whatever was inside the parentheses. So replace u with 1 minus a over b times x. And now what we're going to do is distribute the negative b over a to the 1 and negative a over b times x. So the 1 turns into negative b over a, and then the constants will cancel, the negative b over a and negative a over b. So the coefficient of x will be 1. And then here we have b over a times 1, and then b over a times negative a over b times x. So I distribute that, I get b over a minus x, because the b over a and a over b will cancel, and then plus a constant. But remember, b over a is just a constant, so I'm just going to remove it because I have a constant over here. So think of this b over a getting absorbed by this constant. And so this is my final answer.